Hello, my name is Sai Kolli, and this is my project, which is the short-term effects of magnetic fields on adult plants. So a quick summary of my project is that the Earth is due for a full magnetic field inversion, which is true because it hasn't inverted for 780,000 years, while it normally occurs every 500,000 years. And these inversions have been proven to affect seeds, but it's not known if it affects plants negatively or positively. And so my project is how to test them to see if there are negative or positive effects of magnets on adult plants. So the question for my project was, how will different magnetic fields affect adult plants? And the background info is essentially the same, except the inversions have been proven to affect some animals, and it has been shown that it affects the seed's growth rate and metabolism, but there has been no testing on adult plants and their metabolism or decay rate. So the hypothesis for the project was that the magnetic fields will not affect the plants much, as these plants have been evolving throughout magnetic field inversions, and as such, they could have been accustomed to magnetic field inversions. So constants in this project were 40 milliliters of water every day for each plant, 8 hours of sunlight each day for every plant. The independent variables were magnetic field levels and time. The dependent variables were plant decay, possible growth, and petal color change. And the control group was plants with no magnetic fields in them. So the materials list is as follows: 8 adult primrose plants and a primrose plant is the plant shown in the picture, 12 neodymium magnets, 36 centimeters of tape, 2,240 milliliters of water, a digital camera, and a ruler. So you had to set up 4 groups with 2 plants in each group. So the first group, which we're just going to mark as control, had 2 plants with no magnets affecting the plants. Group 1 is 2 plants with 1 magnet attached and affecting each group or each plant. Group 2 was 2 magnets affecting each plant, and group 3 was 3 magnets affecting each plant. And each group had 2 plants. So I was to test each plant's height, color, and decay each day for 21 days, which was the number of days I tested each plant. And I was to take a picture of each plant each day after testing. And I was to water each plant with 20 milliliters of water every day, twice a day, to ensure the plant stayed alive. So you may have noticed that in the procedure, it noted diagram 1, 2, and 3. And each diagram essentially shows how each magnet should be placed on the plant pot. So after conducting the results, here's the data table. Here's the graph. And here's the same graph with trend bars. So as you can notice, after testing, it shows that there is no real correlation between the magnetic fields and adult plants. The only real consequence was that each plant in every single group started to decay after day 7. So here's 3 plants and pictures of them from day 0 to day 21. As you can see, there's barely any difference. You can just notice that they're slightly decayed more. And so the conclusion was that, as the experiment showed with plant heights, color, and decay rate, that there's no noticeable correlation between the plants and magnetic fields. So after observing the photos taken from the plants from day 0 to day 21, it was also shown that no correlation in change was being shown. As the data showed no real correlation between magnetic fields and plants, this meant that the hypothesis was correct. As the data showed no correlation, there is no real threat to plants when they are exposed to magnetic fields, meaning that plants may not be seriously affected by magnetic fields. There were some trends in the data I'll show you in the graph, but they're not really that noticeable, and they just follow the same random, no correlation that each plant was following. And so, as with any experiment, some errors could have been made in testing. Some possible errors may have been that each plant was tested at slightly different times, as one person couldn't test each plant at the exact same time every single day. And when watering the plants, some water could have been prevented from reaching the soil because of leaves or other mishaps, which could have caused the plants to decay a little bit more. And the last one is just measurement inaccuracy, which is something that would come with any human because of human error. So, so if I continued with this project, I'd explored the really long-term effects of magnetic fields on plants. So maybe like instead of just 21 days, so 3 weeks, instead of that, maybe a month, maybe 2 months, maybe 6 months, maybe a year. This would benefit the gardening community and also just life in general, because if we know that magnetic fields improve plant growth or metabolism, that could help make crops grow faster. And so my inspiration for this project was that I really wanted to crossbreed plants to make them super effective at absorbing carbon dioxide from the air. But because of COVID-19 and the pandemic, I couldn't do that. So I decided to go into a similar plant route, but decided to do something on magnetic fields and how they affect plants. So thank you for listening to my presentation. And yeah, thank you.